So I'm Chris Swan, CTO at Cohesive Networks. And I'm going to start off just kind of setting the scene and looking backwards a little bit. So this is a picture I drew, I think, around about 2004. And I was over the road in Credit Suisse, and at the time running an engineering program around web services management. And our thinking at the time was that everything was going to have a web service, because web services was what we were calling APIs at the time. And we kind of came up with this triangle of web services management and clients and services and registries, and thinking about how we could make things secure. And we had this thing called the Enterprise Security Framework, which incorporated some aspects of what became WS security. And we were trying to make things fast. And I'll talk a little bit more about XML in a moment and some of the challenges that came up around XML. But it's pretty obvious to me now why XML turned out to be a bad idea. And we were also trying to make things reliable. So you saw horrible standards like WSRM coming along, trying to make HTTP do the same things that asynchronous messaging systems did. And if I recall back to those days, a lot of stuff just got really badly bent out of shape. And at the center of all of this was SOAP. And if you think what SOAP actually means, Simple Object Access Protocol, it was an awful lot of complexity for something that was supposed to be simple. And what it actually made simple was the lives of Java and C# developers, because those two languages have got truly awful HTTP libraries. And so coding against REST from those two languages is still pretty awful. And SOAP, and more particularly WSDL, made life easy, because you could take a lump of WSDL and you could put it through a preprocessor and it would generate all of your language bindings for you. Job done. No need to worry at all about nasty HTTP libraries. So it all went horribly wrong, and WS star turned into WS Death Star. And I think a lot of this was driven by the vendors. So you had people in rooms doing standards body stuff, concocting things that they thought they could make product out of without any regard whatsoever to user need, and making life easy for developers, and helping people build things that were going to be really accessible. And so this kind of doomsday scenario that we'd been envisaging of everything would have a web service, and so we would need to manage the gazillions of services that went along with it, didn't quite happen, because it kind of crashed on the rocks of this WS-star thing. And I said I'd touch upon XML and why XML turned out to be so problematic. And I think at the heart of this was asymmetry of effort. So making a service, making XML, turns out to be really, really super easy. So you get whatever you've got in your object and you serialize it into strings with angle brackets around it. And it's computationally not very difficult at all. And consuming XML is atrociously hard. So taking all of that lump of string and turning it back into a serialized object turns out to be a really difficult and complex problem. And so, people complain now about things like proof of work in protocols like Bitcoin. And it feels like if you look back to those days, we were running a proof of work exercise and trying to get data out of services. And actually, it was worse than that, because the data was almost invariably at the time ending up in a relational database. And we always went the long way around. So I never actually saw a system that went straight from XML to relational, because that would involve coding everything directly against the database, and the database understanding XML in the first place, which some of them did, but not particularly well. So it was all going through an object on the way there. So first of all, you had the impedance mismatch of deserializing your XML into objects, and then you had another impedance mismatch going across your object relational mapper into the database. So this was just far too hard, and this is why we ended up much preferring JSON, because it's got a lot fewer of those problems. Come on. So, title of this talk invokes the Audit Paradox, and this is something I sort of came up with a few years back. And it's about the difficulty in putting security around our services and how we actually go about doing that security. So if you talk to security people, and I've spent my time being a security person, and I think security is like the Hotel California of IT. So I occasionally get to check out and pretend that I'm not a security guy for a while, but it always drags you back in. And so they'll tell you, when you're building systems, if you want to build a secure system, you need to build security in. And so just like this pretty piece of brickwork here, where somebody's built in the name of something, your security of your system should be better if you've built it in from the very start. So what does building in look like? Well, building in looks like, this is a sample of something like 43 pages of guidance, which I picked out of the Microsoft Developer Network, because Microsoft, back in the web services days, were still recovering from their reputation around security. But they came up with the secure software development lifecycle, and they kind of fought their way back, and actually these days make some of the most secure software from large vendors on the planet. So they're not bad at that stuff. And the developers I used to work with on services projects would say to me, why can't I just follow the guidance in the MSDN website, and I will make a secure web service? I'll put this together in C#, or you can take equivalent things with Java or whatever else, and I can make sure that I'm doing schema validation. I can make sure that I'm checking my payloads to avoid buffer overflows and cross-site scripting and all of the sort of attacks that we get. And the sort of answer to that's a difficult one, because it's sort of, okay, you say you're going to do all of those things, and how do I actually know? Worse still, when it comes to an auditor coming along, how does the auditor know that you've done those things? And it actually involves going into all of the source code, and it involves sort of going to the 43 pages of guidance and cross-referencing them against all the source code. And that's basically an impossible task, which is why we end up bolting on our security instead. And if we look at how bolt-on security is delivered, we get it like this. So we get a box. You can take the box, plug it into the network. It stands between the service that you're exposing and the outside world and all the bad, nasty people out there. It's exactly like the firewall model that enterprises, at least at the time, were comfortable with. And it's got independent configuration. So the config that's going into the box is not part of the source code. It's not having to rely upon 43 pages of MSDN guidance to get it right. The box's sole purpose in life is to sit there and make things behind it be secure. And it's got a relatively small lump of config saying what's allowed and what's not, which an auditor can come along and look at. And that's the audit paradox. The audit paradox is we use the bolt-on security mechanism, the box, because it helps us keep the auditor happy, rather than the build-in mechanism, which everybody knows to be the better way of making systems secure in the first place. So that's a bit of a challenge. So there was another challenge, which is these boxes aren't cheap. So one box on its own isn't atrociously expensive, but when you're talking about an enterprise deployment, you're basically talking about a ticket of about $250,000 just to get the boxes, never mind to build an organization around caring and feeding for them. When you think that, you're probably talking about $1 million. And this became an obstacle to services deployment, because you had to buy the restaurant in order to have the first dinner. So every part of the organization was saying, it would be great if we could just expose this little service to our customers, was confronted with a $250,000 hardware bill and the need to get headcount to look after that in order to do something about it. Things are getting better, though. So we can look at the sort of shifting sands of the technology landscape. So if we look at all of the other boxes we had in a perimeter, firewalls and network intrusion detection and antivirus and anti-spam and VPN gateways and data leakage prevention and load balancers and da-da-da-da-da. All of those things got squeezed together, and we now call that unified threat management. And at least that's just one box. The same for a lot of the things that we run as network application services, so the load balancers and content caches and TLS offload and da-da-da-da-da. They've all been squeezed together into what we call application delivery controllers, which is another box, sits at the edge of the network. So at least we've got fewer boxes now. And you can kind of see a place where the kind of XML-specific or even now API-specific functionality that we might concern ourselves with can at least be squeezed into one of these Swiss Army knife boxes and become part of the kind of regular scene. So you're not having to buy another box just to get your API out there. Platform as a service gives us a chance to bolt functionality in. So I'm kind of going to repeat that a little bit, bolt in. So instead of building our security in, it's been built into the platform. So it's not an application-specific or a service-specific thing. It's not a concern of the developers. It's a concern of the platform builders. And the platform as a service comes with it built in already. So we've got security there that's built into the platform, not built into the application code. And as a consequence of that, it's also got configuration which tends to be independently auditable and verifiable. So this is the wonderful thing that gets us around the audit paradox. So if we can adopt platform as a service, then it helps us tackle the audit paradox. And there's a snag with that, which is the tremendous popularity of containerized platforms such as Docker. Shows us that there is a movement against opinionated platforms. So this is starting to look to me like something that works along a trust axis, where we're in high trust environments, where we've got developers that we trust to get on with doing their own things. Then we can give them a less opinionated platform. So they can do their own stuff, put it into a container, deploy it into their microservices environment or whatever they're working with, and off we go. And opinionated platforms are things that are the preserve of low trust environments and generally lower skill environments where we don't trust the developers to build in their own security, etc. So we make it part of the platform. That constrains their freedom to maneuver, but it also constrains their freedom to make mistakes. And so that's a trade-off. By the way, very proud day for me today. First contribution to Docker core got accepted overnight. A side note here is if a security event happens and it isn't monitored, then it's a bit like the age-old question of if a tree falls in a forest with nobody there to hear it, does it make any noise? So if you are not putting your security events into a monitoring system, which can ultimately get a human out of bed and make them fix something, then you probably shouldn't even bother with that security control in the first place, because the best it will accomplish for you is to be a record of what went disastrously wrong when you noticed it some other way. So I'm going to kind of wander more into my day job a little here with software-defined networking and networking function virtualization. And we're now at a point in time where networks, and especially the security controls that we've previously thought about putting into networks, can be made from and configured by software. So these two fancy terms, NFV and SDN, I try and simplify those with saying network function virtualization is simply networks that are made out of software, and software-defined networking is simply networks that are configured by software, APIs to networks. And of course, there's a massive overlap between those two things, because who in their right minds is going to make a network out of software in 2015 and not put an API onto it so that it can be configured and managed at scale? There are people doing that, but it's I think that's a bit of a niche activity at this point in the game. So what that allows us to do is we can take a bunch of networky things, switches, routers, firewalls, VPNs, and we can put them into, let's say, a virtual machine. And we can take a whole bunch of other networky things, network application services, security services, whatever we like, and we could put those into containers. And we can run those containers on the same virtual machine as the core network functions if we want to do that. So this is giving us lots and lots of flexibility over deployment. And what that allows us to do is to start to think about these perimeters as being application or service-centric rather than an enterprise perimeter. Because we're no longer dealing with those lumps of hardware. So we don't have the cost of racking and stacking things. But more importantly, because all of this stuff is API-driven, we don't actually have to now think about network operations people sat at command lines working trouble tickets in order to configure this stuff. It can become part of an automated orchestration. So just as you're deploying the application code with your config management tool of choice, you can build the security perimeter around that at the same time with the same config management tools. And that previous picture was somewhat enterprise application oriented, but the same things refactor into microservices. So we can make security services just part of our overall application microservice deployment. So it just becomes embedded in the overall architecture. There are some challenges remaining. And they're important challenges, and they're the challenges that the people in this room need to think about and get on with tackling. So if we're going to get to a world not just of DevOps, but of secure DevOps, where we're not just delivering our stuff into production very frequently and very, very agilely, but we're doing that and being secure at the same time, will you stop auto-advancing? It'll definitely stop there. APIs, and APIs to the network in particular, they're necessary but not sufficient. So it's good that we have APIs. It's good that software-defined networking is giving us APIs to network. It's good that we have APIs more generally to the things that we want to manage in our environments, as well as the services that we want to expose. But they need to be integrated into an overall system. So when Arno did his introduction yesterday, he kind of made the point of it's the interface that's important. But the interface is only important when it's being used. And so there needs to be an overall system that it becomes part of. Control metadata, and particularly its mutability, must be visible and, more importantly, understandable. So it's not good enough that it's just visible. It needs to make sense to people. So returning to this question of the audit paradox, the control metadata, especially around our security controls, is defining the state of our security. If that control metadata is mutable, that means that people can come along and change the state of our security. So you need to first of all ask yourself a question of, am I okay with that? The answer could be, yes, you are okay with that. There just needs to be perhaps some compensating controls around that mutability. It makes you think that immutability of security controlled metadata might be a good thing. And then you can ask yourself how you're going to accomplish that. But to really solve that audit paradox, people need to be able to come along and look at this stuff and know what it means and be able to explain that to an auditor and an auditor explain that to a regulator, that we have set a set of controls in such a way that we are doing what is expected of us. We're doing the right thing for our customers, we're doing the right thing for the organization, and we're doing the right thing in terms of the legal frameworks that we operate within. And then to my earlier point about monitoring, security events need to be captured, and then they need to be turned into something that humans can act upon. So don't just have everything just feeding into a system of logging, but it actually needs to be analyzed, and you need to be able to deal with all of the false positives that you get out of a lot of these systems, and from all of that, make sense of it such that when something bad is actually happening, you can take the appropriate action. I'd return actually to some of the stuff around application-centric perimeters and say the good thing there is at least you can have reduced rule sets. So you're worrying only about the contents of that application or that service and the data it's managing, not the kitchen sink of an entire enterprise's worth of stuff and all of the inherent conflicts that you get with that in terms of every conceivable application and all of the infrastructure it's running on. So you can have much more focused rule sets by taking that micro-perimeterization approach. So that, I hope, has been a very quick canter through the problems that we had in the past with web services security, the evolution that we're going through at the moment in terms of not just delivering APIs, but using APIs as part of the solution to problems that we now have with security. And hopefully a glimpse into the future of a world of secure DevOps, where we can start to make use of these things as part of overall automated applications and infrastructures that are delivering services, whether that's a microservices architecture or something more traditional. Thank you very much for listening, and I'll take questions if there are any.
I have a question about the assumption, I guess, is that no matter how much we put into the perimeter, somebody like the teller solution is going to find a way through. So that leads me to consider what can we do about the integrity of the data itself. And the only option on the table at the moment is to encrypt everything and encrypt everything at rest. Is there anything else happening in that space that focuses on the integrity of the data that doesn't require that type of heavy investment in encryption of data?
So a very wise man in the industry called Gunnar Peterson tells us that there are only actually two things we can do in security. So we can do state checking, number one. So we can take our expected state and compare it to the state we have and look for anomalies there. And we can do encryption. They're the only two things we have. They're the only two weapons in our arsenal. And so you should absolutely be using both as much as you possibly can. Encryption isn't expensive. People selling you encryption products might put big price tags on them, but the cost of doing encryption from a sort of machine standpoint has come down massively. And people still worry about TLS termination in software. It's like that's a 1999 worry, not a 2015 worry. And certainly, using AES block ciphers, even at 256-bit, is essentially trivial as a computational overhead. So just make use of it. Key management is still the difficult part, and I think we're starting to get much better at it. So we're seeing a whole bunch of key management solutions, secret management solutions coming to market now. I think we're on the verge of something where we're going to see some high-quality industry standards around that. And I was having a conversation last week that perhaps we should do the same thing that we've done with the cloud and just assume that the AWS way of doing it is the best way and just go with it. So take the KMS API and say, okay, let's just standardize around that. Let's just copy the KMS API, ignore the recent judgment about the Java APIs, and hope that eventually the Supreme Court in the US sees some sense about that, and make use of what we've got there. Because I think until we have industry de facto standard, at least, key management APIs, this stuff from a development standpoint just becomes trickier than it needs to be. But yeah, don't be scared of encryption. Embrace it. Make use of it. Now, if we take the teller example, a key point to see there is these are authenticated users. So although Stevie was breaking through all of the obfuscation and some of the key management and everything else yesterday, at its heart, he was still an authenticated user making use of a pucker set of credentials. And so identity management is still another thing that it's super important to get right and keep an eye on. And I think one of my frustrations when I was working at the banks was I saw that a great skill of ours was managing identities. We issued account numbers, we did know your customer, we jumped through all of these hoops. But we were so reluctant to think of ourselves as an identity-based platform. And especially to embrace things like federation. And I think there's still a huge latent opportunity in the banking business to say, actually, one of our key strengths is knowing our customers and issuing them with identities. And having successfully done that, what more can we do with that? How does that enable us to deliver better services to them? That's where I'd be focusing my attention. The encryption piece kind of follows from secure knowledge of identity of the people that we're dealing with. And when you kind of go to the hard pieces of that, you get into things like the NIST level of assurance model. A lot of the work I did at my last bank was around the higher degrees of that. So at level of assurance 3, you're doing two-factor authentication with soft credentials. 4, you're going into hard PKI. You can still do delightful user experiences and be secure. We're starting to see some of that come to market with things like Apple Pay. And it's having confidence in those systems and thinking about making them as super easy for the user as possible.